My name is Kaushik Burman and today I'm here to put an emphasis on NEET 2020. Okay, so we've all come to know that NEET 2020 has been postponed for a later date, that is July 26, and keeping that in mind, today I'm going to give a planned schedule how to prepare for these NEET examinations, and most importantly, what are the important topics that this NEET 2020 would cover. So, as far all the things are concerned, physics is generally taken as a tough competitor when you are preparing for NEET preparations and NEET examinations all throughout the country. Now, in order to prepare for subjects like physics, you need to be very smart in choosing the right chapters, in choosing the important questions to prepare for your subject. Now, talking about the right chapters, let me first show you what are the chapters that cover a major chunk of the NEET portion. So, the first important chapter that we need to discuss about is actually electrostatics. Now, electrostatics basically contains the first two chapters of your class 12 portion. Now, electrostatics is not a singular topic. When you're dealing with electrostatics, I'd also like to let you know that there is a similar chapter called gravitation in class 11, which is very much similar to electrostatics. So once you're preparing with a chapter like this, you need to be also very fine with linking up the rest of the chapters which are exactly equivalent to a 4 more chapter. So in that way, you can reduce your portion to a little more amount. Now, talking about electrostatics, I'll come to the next point later on, but there's an important connection that I would like to let you know. That is, when you're doing this chapter, I'll also suggest you to look down the other chapters. Now, what would be the other chapters if you look down? After electrostatics, you'd come down with something like magnetism. Now, magnetism also contains 2 chapters. Okay, we'll be discussing that in the later part. After the 2 chapters of magnetism, we'll come to AC, that is alternating current. And later on, we'll be talking about electromagnetic waves. Now, the whole portion can be considered in a single topic of electrostatics plus electrodynamics. Now, when you combine these 2 topics of electrostatics and electrodynamics, that would include this part of the physics portion. And mind it, this part of the physics portion actually covers the very first priority of your NEET preparation. So, we'll be starting with the very first chapter, that is electrostatics. And we'll be planning throughout in our classes how to deal with these important chapters. So, let's get started first. Okay. So, as I said, we'll be starting with electrostatics. Now, let me give you some important points about electrostatics before we started with the chapter. And mind it, every important detail, whether be theoretical or numerical, is very important for your NEET preparation. So, I want everybody to pay full attention to even the smaller details that we'll be discussing in this video. Let's start. So, when we talk about electrostatics, we basically talk about charges. Okay, so let me write down charges. So first of all, we need to know what is actually a charge. Before that, let us come to the name of the chapter. What does the name signify? So when I talk about electrostatics, as I said, electrostatic is a chapter that will completely deal with charges. Now before coming to charges, let us put an emphasis on the name. Electrostatics. Now static means to be at rest. So when we are dealing with electrostatics, this is actually that branch of physics which deals with charges at rest. Matlab, when this charge would be completely at rest, when there is no velocity of the charge, that is when the whole branch will be dealing with static charges. And that kind of physical study of static charges falls under the banner of electrostatics. Now, when a charge acquires a particular velocity, the whole branch of physics would shift from electrostatics to electrodynamics. Now, how do you distinguish between that? So, let me give you 3 important points. Charges at rest, charges at motion. Now, when you talk about rest and when you talk about motion, there are 2 more important points that you need to know. When we talk about motion, there are 2 types of motion. One is uniform motion, the other is accelerated motion. Now, when we talk about rest, that is when we'll be dealing with electrostatics. That means the charge will only deal with electric fields. But when we talk about the same charge in motion, that is when we will not only get electric field but on top of that, we are also going to get or encounter one more field. That field is known as the magnetic field. So whenever there is uniform motion means what? Your acceleration would be zero. And in that kind of a situation, we will get an electric field plus we'll also get a magnetic field from the same charge. But when the same charge is in an accelerated motion, what is accelerated motion? Accelerated motion is a motion where acceleration would not be equal to zero. In that case, we will not only get electric field and magnetic field, but on top of that, combining both of them, the next important thing that we'll be getting here is electromagnetic wave. So this electromagnetic wave is actually the last chapter that I showed you in the priority circle. So when you know about this kind of things, it makes us easy to combine all of the 5 to 6 chapters in a single topic and understand it thoroughly. So you need to understand how to link chapters, how to link concepts. This is a very important concept, and mind it, there is an important question that was been asked in previous NEET examination based on this information. Now let us take forward and move forward from this particular point. So as we say, the whole chapter of electrostatics and even electrodynamics will be dealing with one single important quantity, that is charge. Now let us find a very interesting way of the concept of charge. Where does this term charge come from and what it actually means? Now talking about everything basically that matter is made up of is nothing but atoms. Now what does atom contain? A particular atom contains 3 subatomic particles, that is electron, proton and neutron. Now when you talk about these 3 subatomic particles, in further investigation we also come to know that these particles have a very negligible mass, and of the 3 particles, the foremost 2 particles also have a particular charge. Now let me just write it. So when you talk about electron, an electron has a mass of around 9.1 into 10 to the power minus 31 kg, and it is a charge of around 1.6 into 10 to the power minus 19 coulomb. Okay, we'll be discussing why I'm talking about charges. We'll be discussing about that point. Again, when you talk about proton, a proton is around 1836 times the mass of an electron, and its charge is basically the positive of the same amount of the charge that an electron carries. And the third particle, that is a neutron, it's basically chargeless. Neutron does not have any kind of positive or negative charges, but it has a mass, and that mass is nearly equal to the mass of a proton. Okay, so these are the 3 subatomic particles that makes up atoms, and atoms as a whole make us all the matter that the universe contains. Now why am I telling you this concept? Because there is a very important link that you need to now understand. Now if you put forward your memory, there's a very important chapter in class 11 that we keep in a lower priority list, and that is the first chapter, the physical world. In that chapter, we come across 4 fundamental forces of nature. Do you guys remember? The 4 fundamental forces of nature are basically what? Gravitational force, strong forces, weak forces, and electromagnetic forces. These are the 4 fundamental forces of nature. Now, talking about the 4 fundamental forces, the very first force of these 4 was gravitational force, and that was actually studied by none other than Sir Newton himself. So what was gravitational force, and why am I talking about gravitational force in this chapter? Let us try to link this part with the chapter of electrostatics. So what is gravitational force? As per Newton stated, gravitational forces between any 2 bodies of mass m1 and m2 separated by a distance r is given by g m1 m2 by r squared. This formula gives us the magnitude of the gravitational force between any 2 bodies having masses m1 and m2 separated by a distance r. Try to remember this formula, F equals to G m1 m2 by r squared. Here G is known as the universal gravitational constant. It has got a constant value all throughout the universe. Now, the very important thing that you need to understand here is when Coulomb was actually understanding about this experiment, he also tried to do one of his own experiment. That experiment was further known as Coulomb's torsion balance experiment. So what was that experiment all about? Now, if you replace these 2 bodies M1 and M2 with the subatomic particles that I have just discussed, electron, proton and neutron, what are we going to get the force as? Now let me try to understand that. So when Coulomb started to perform his own experiment taking the subatomic particles, I'll try to make you understand this part in a three-way experiment. Let us first take the subatomic particles to be an electron and a neutron separated by the same distance r. In the next case, we'll be considering electron and an electron, and in the thirdmost case, we'll be considering an electron and a proton separated by the distance r. You can take out different arrangements, but this three arrangement will make us clear about why am I talking about gravitational forces and how is it actually linked to electrostatic forces. Okay, now when he took an electron and a neutron separated by a distance r, first of all he took out the gravitational force that was given by g m1 m2 by r square, and taking the masses of electron and a neutron, he also found out that this force is equivalent to an experimental force. I will talk about what is the experimental force is all about. So that F experimental was actually equal to the force of gravitation. Now in the next two cases, when he performed the same experiment, he again found out the gravitational force by taking the formula g m1 m2 by r square. But in this case, the F experimental, which I am talking about, that F experimental was much bigger than the gravitational force. Again, he did the experiment by taking an electron and a proton. He found out the force of gravitation, and then he again found out an experimental force. In this case as well, we found that the experimental force was much greater than the gravitational force. So at that point of time, Coulomb came to realize that gravitation is not the only forces that binds two bodies together. There are other forces governing the subatomic particles, and those forces are much larger than the gravitational force. And upon further investigation in the later years, it was found out that this experimental force was around 10 to the power 40 times, which is huge. 10 to the power 40 times greater than the gravitational force. So what was this force? And how are we going to name this force? Again, upon further investigation, he also found out that the F experimental values in the first, in the third and the second case, mind it, the F experimental value in the second and the third case was exactly equal in magnitude, but with an opposite sign. Now, why are these sign conventions coming in this kind of forces? Why this force is so much greater than the gravitational force? So that is when Coulomb stated that every atom, rather than showing gravitational interaction, also show a different kind of interaction. That interaction is much bigger than the gravitational interaction, and that interaction is actually between the subatomic particles, and the interaction comes out with different parameters. By parameters I mean the interaction might be a positive interaction or might be a negative interaction, depending what kind of a subatomic particle we are dealing with. So with all this investigation taking place, Coulomb said that there is one more property of matter that deals with different kind of interactions, and these interactions were further named as electromagnetic interactions. So electromagnetic interaction is the property shown by a different kind of a thing, and that thing which shows this kind of a behavior or which shows this kind of interaction was finally named as charges. So electron and proton, these are actually the subatomic particles that plays the basic role of charges in our life, and how these charges interact, that is what we are going to learn in the next part of this video. So we have come to know the origin of charges, where it comes from. The charges actually come from the basic subatomic level of an atom, and those charges are actually showing two important things. So I'll just point those out. It's a property of a matter. Every matter will contain charges. Why? Because every matter is made up of atoms, and atoms has got subatomic particles, electron, proton and neutron. Out of that, proton and electron will have the charges, that is positive charge for proton and negative charges for electron. The basic things of positive and negative charges I'm not explaining in detail, because I already assume you guys know those things, because we have already learned those in class 9 and 10. So coming into the important part, a charge can be defined as something as a property of a matter, and that particular property of matter actually shows what kind of interactions. It shows electromagnetic interactions. Now, going further into the details, as we see, a charge can either be a positive charge or it can either be a negative charge, right? Now, what kind of an interaction does these charges show? We already know this, so I'll just state that in smaller details, and then we'll go to the next part of the chapter. So, when we talk about two same charges, that is like charges, okay, it might be positive or a positive, or it might be negative or a negative. So when we talk about like charges always repel each other. It's a property of charge to repel when they are of the same nature. When we talk about unlike charges, like positive or a negative, then the interaction between a positive and a negative charge is always attractive. That is, when the charges are of opposite nature, they attract each other. That is the property of charge. Now, what are the important characteristics of these kind of charges? Before that, we'd like to understand some of the important things about a charge. So let me just write it up for you guys. So now let us discuss the formula, the unit and the dimension of a charge. So the formula of the charge comes from a very simple formula that you have already learned in class 10. Do you guys remember the formula for current? Current I was given by charge per unit time, right? This Q represents charge. So Q would be given by what? Current into time. So this is one of the very basic formula of charge. Now, talking about the unit. What is the unit of charge? So, the SI unit of charge is Coulomb. That is in honor of the scientist Charles Coulomb. Now, you not only need to know SI unit because 1 coulomb of charge is actually quite huge. Not just huge, it's humongously huge. So, we also need to know about the subunits. That means the smaller units other than coulomb. The smaller units other than coulomb that are generally used are millicoulomb, microcoulomb, and nanocoulomb. Millicoulomb is nothing but 10 to the power minus 3 coulomb. Micro is 10 to the power minus 6 coulomb. Nano is 10 to the power minus 9 coulomb. And there are other types of smaller units like pico, fermi and other all. Now, this is about the SI unit. There was once a simple question which was asked a couple of years back, I suppose. The CGS unit of charge. Now, do you guys remember what is the CGS unit of charge? The CGS unit of charge is basically given as ESU. Now, what does ESU stands for? There is another short form as well, but this basically is known as state coulomb. So, state coulomb is actually the CGS unit of charge. Now, what does the value signify? A state coulomb is equal to 3.36 into 10 to the power minus 16 coulomb, which is very, very smaller than the value of 1 coulomb, right? It's 3.36 into 10 to the power minus 16 coulomb. Okay, now this state coulomb sometimes is also known as Franklin. That is also the name that is given to one ESU unit, that is Franklin. Now, other than this, what is the biggest unit of charge? The biggest unit of charge is also something that you guys will need to understand and need to remember as well. The biggest unit of charge is Faraday. In honor of the scientist Michael Faraday. So 1 Faraday is equal to how much? 96500 coulomb. That is the biggest unit of charge. Now let us discuss about the other things. We'll be discussing that in the next video.